In this lesson, we're going to look at solving a system of equations just like we've done in the past, except this time we are going to have three equations with three variables. So when we introduce this third variable, it's usually the variable z, and when we graph it, it's actually like an axis. It's almost 3D. It would be a vertical line coming out of your paper, essentially. The y is the vertical, the x is the horizontal, and the z is kind of coming out in between those, I guess, if you will. So the solution to a system with three variables would have three solutions for each variable, and it's an ordered triple, x, y, z. So instead of just x, y, we have x, y, z. So what happens is these planes, so like if you're looking at that first image there, this would be the y plane. This would be your x. So this one here is the z. So if you're not a visual person, I get it's kind of tricky to understand, but all three of those planes intersect at one point. That would be your ordered triple, your x, y, z. So infinitely many solutions would be if they intersect at a line. So instead of all meeting at one point, if they're all sort of lined up together and intersect on what would be a line, then you would have an infinitely many number of solutions because there's infinitely many number of points on a line. So there would be no solution if your planes don't intersect all together. Two of them can intersect, one of them can intersect, but if not all three of them intersect together, then there's no solution. And that's what these bottom three are trying to tell you here. So over on the right, it does sort of give you guys steps. I think it's a little confusing, so we're going to go through one or two examples. But what's going to happen is you're going to still choose a variable to eliminate like you normally would, but you're going to eliminate that variable with two of the equations. So you're going to have to multiply a number twice instead of sometimes just that one time like you used to have to do. So you're going to eliminate that same variable with the third equation and one of the other original equations, just like we've done before, just a little bit more involved this time. So what happens is you use the equations created from steps 2 and 3 then to write a regular systems of equations like we've done in the past and solve for them. So that's where you can use your substitution or your elimination there. And then you guys just solve for the eliminated variable by replacing your answers from step 4. So once you've solved that for that second variable, we plug it back in. That's a lot of words. So let's go down and look at one. So if we look at example 1, you first want to look at that and say, okay, what kind of looks out of my x, my y's, and my z's, x, y, z's, which one kind of looks like it might be the easiest to eliminate? So if I'm looking at my y's, I've got 2, 5, and 4. My z's, I've got 3, 4, and 1. So it really doesn't matter which one you choose to eliminate. I'm just going to choose to eliminate the x. So I'm going to use this equation and I'm going to manipulate this one to eliminate this x variable. So if I'm using that middle equation, if I want to get rid of the x's, we currently have 2x. So we need a negative 2x to eliminate the x variable there. So we're going to just multiply that negative 2 in there, remember, to everything, and get negative 2x minus 4y plus 6z equals 6. And there's a lot of steps involved here, so just take your time and don't rush. I may even mess up once or twice. In doing this, just take your time. And then we will add it to that original equation highlighted there. So when we do that, the x's should go away. Negative 4 plus negative 5 is negative 9y. We have 10. Z equals 6 plus 13 is 19. Okay, so that's just one equation. We need two of these so that we can actually eliminate one more variable. So what I'm going to do, let me get a different color here. I'm going to now use this equation, but I'm still eliminating x. So if that equation has 5x, we want this equation to have a negative 5x. So now we will multiply this in here to everything and get negative 5x minus 10y plus 15z equals 15, and we will add it to that original highlighted equation there. So your x's should go away. We now have negative 6y. We now have 14z equals 20. So these two new equations now with only two variables is what we want to solve like we used to know how to do when there was only two variables. So I'm going to rewrite those right next to each other. So negative 9y plus 10z. This is the part you guys know how to do. Negative 6y plus 14z. I forgot to put my top one equals. Top one equals 19. Bottom one equals 20. So now this is like the regular systems of two equations that you guys know how to do from Algebra 1. So if we're just going to solve it doing elimination, let's just multiply so that we get the same but opposite. Let's just multiply this equation by negative 2 to get 18 and multiply this one by 3. So we've got positive now 18y minus 20z equals negative 38 and negative 18y and 14 times 3, 42z equals 60. So when you guys add them up, you get 22z equals 22. So z is 1. So we have the first of our three variables. Now we're going to plug in z into one of those two equations on the left there that have just the two variables. So we just have to hope that we've done all of our math right so that when we plug them into here, it will work for us. So negative 9y is what we're solving for, plus 10 times 1 equals 19. So negative 9y plus 10, you'll subtract that 10 over, get negative 9y equals 9. So y equals negative 1. So we've got our y now. And then you have to plug z and y in one last time to get your third variable, which in this case is x. So I'm just going to plug it into one of the original. So let's just do the blue highlighted equation. 2x minus 5y plus 4z. So 2x minus 5 times, we now know y is negative 1, plus 4, we now know z is 1, equals 13. And then you guys just solve. So 2x plus 5 plus 4 equals 13. So 2x plus 9 equals 13. You guys will subtract that 9 over. Get 2x equals 4. So x equals 2 when you guys divide. So we do want to write this as a ordered triple. So we just do x, y, z. So 2, -1, 1. And that's it.